Let's take a look at problem 6b, sample problem 6b from page 211. It gives us an example of a car moving, 1,400 kilogram car, moving with an initial velocity of 15 meters per second to the west, collides with a utility pole and brought to rest. So that's 0 meters per second. And it says that this happens, okay, so our change in time is 0.3 of a second. So it's asking for the force. We want to know at what force does this hit the pole. So we are going to use our impulse momentum theorem, and that's what we have right here. And it states, part of it, the second part, force times change in time equals mass times final velocity minus mass times initial velocity. So if I just divide this change in time, that's how I come up with this formula. Because I now know my mass, my final velocity is 0, okay, right here, minus my mass times my initial velocity, which was 15 meters per second to the west, all over my change in time, which was 0.3 of a second. So what we're going to do now is just go ahead and plug these values in. So I'm going to say my force equals, now this first part, this mass times final velocity, well, my final velocity is 0, so that value is going to be 0. So it's going to equal a negative, and I'm saying negative because it's subtraction, and it's going to be negative my mass, 1,400 kilograms, times my initial velocity. My initial velocity on this one was 15 meters per second to the west. And we'll take a look at that, the west part here in just a second. All over 0.3 of a second. Now if we plug this in, what we're going to end up getting is negative 21,000 kilogram times meters per second over 0.30 seconds. So from here, if I do my division, negative 21,000 divided by 0.30, what we need to remember is these seconds are actually both on the same part of this fraction. They're both in my denominator. So what I'm actually going to end up getting is negative 7.0 times 10 to the fourth kilogram times meters per second squared. And it's going to be west because our initial velocity here was to the west. But taking into account also now that it's negative means it's going to change direction. So my force is going to be a positive 7.0 times 10 to the fourth, and kilogram times meters per second squared, which ends up being a Newton. And my direction is going to be to the east. And it's to the east because negative west is east.